Today we got logarithmic functions and graphs. Another thing, hopefully you've seen a little bit of this in Algebra 2. If not, we got it. Two hugely important properties. The first one says this is how logs work. Log base a of x equals y. Basically, you do this. You do a to the y power. Let me erase that real quick so I clean it up some. Okay, basically you do a to the y power equals x. Makes like a circle. A to the y power equals x. That's what makes that log true. That log is true if a to the y equals x. Also, because that's the case, a to the 0 is 1. So if you see log of any base right here, base a, base whatever, and there's a 1, it's always going to equal 0 because anything to the 0 power is 1. This one, a to the first power is a. So anytime you see these two numbers here are exactly the same, it's always going to equal 1 because a number to the first power is always itself. Remember, that's how log works. The base to that power equals 1. The base to that power equals that number. A to the y equals x. I'm drawing all over the place. Let's see. Let's work a couple here. Okay. So let's find each of the following logarithms. So the first one's basically saying, because the base is 10, 10 to what power is 10,000? And because 10,000 has 4 zeros, it would be 4. So the answer to a log is an exponent. A log is the inverse of an exponential equation or exponent, so the answer is the exponent. So the second one says log base 10 of really 1/100th, and because it's a decimal, which is really a fraction, 0.01 is really 1/100th. What power would you raise 10 to get 100? Well, first of all, you'd raise it to the second power, but because it's been flipped, you would say -2. The answer is the exponent. Third one, log base 5 of 125. It's asking you 5 to what power is 125? The third. Part D, log base 9 of 3. So it's asking you 9 to what power is 3? What power would you raise 9 to get 3? Well, first of all, we know that 9 is the square root of 3. That means it's going to be a fraction exponent like 1/2. Remember, bottom is the root, top is the power. Square root of 9 is 3 to the first power. And finally, this is asking 6 to what power is 1. That's obviously 0 because anything to the 0 power is 1. Hope that slide made some sense. Look at the next one. So let's convert each to a log equation. All right, so basically, whatever the base is up here is going to be the base in your log. So I'm going to say log base 2 of 16. Remember, the answer to log is the exponent. You can check it. 2 to the x power equals 16. Okay, look at the next one. I'm going to say log base 10 of 0.001. Remember, the answer, or what it equals, is the exponent. Is 10 to the -3 0.001? Yes, it is. The second part of this slide says convert each to exponential. So I'm going to take the base, 2, raise it to the 5th power, and it should equal 32. You're not trying to find an answer here. They're just making you practice how logs actually work. Part B, a to the 8th power is q. All you do. Okay, just again, making you practice how logs work. Okay, find the following common and natural logs on your calculator. Round to 4 decimal places. All right, so all you have to do is punch those straight in. So what I went ahead and did is I went ahead and punched them in, took a picture of my calculator, and here it is. Log 645,778, punched it in, got 4 decimals. Log, the second one right there. The third one, the part C, I tried to punch that one in. Actually, I didn't because I know it was going to be, but you cannot do a negative log. You cannot have a log of a negative number. And if you do that on your calculator, it's going to give you a big error message. All right. Also, in case you don't know, the log button on your calculator is, you can barely see it on my picture. It's right there though, and the natural log button, the LN button, is right there. So that's where the buttons are, in case you can't find them, which I think you can. Okay, so then it said to do natural log or LN 645, and you can see I did that, and it also said natural log of the second one that we did, 0.000239. So did those and got those answers. Also notice 2 of them were negative. The negative answers were the decimals because they turned into fractions, which means you had to flip the base 10. Oh, should have said this too. Common log means base 10. So notice, if you notice those first 3 up here did not have a base written. If you don't see a base, that's called a common log, which is base 10. Also the second, the D through H problems, there's also no base. If you see a natural log, it's always base E. And if you look at your calculator above, you can barely see it, but above the log, well, you can't see it. But if you look at your calculator, above the log button, it says 10 to the X. Above that natural log button, it says E to the X. And that's why. Okay, the last two, I didn't put those in the calculator because you don't need to. Remember, when you see a natural log, it's really base e. So it's asking you e to what power is e? The first power. E to the first power is e. The second one is really asking you base e. E to what power is 1? Well, anything to the 0 power is 1, so it's just 0 right there. All right, change of base. This is pretty handy. If you have a log like this, log base b of m, you can rewrite it and change it to any base you want to, as long as you put log of m over log of b. The base stays on the bottom. And I didn't put a base on there because most of the time when people do this, they change it to base 10 because that's what your calculator knows. So this next problem says find log base 5 of 8 using common or natural logs, because you can't punch in, like, you can't do 5 to some power is 8 and figure that out in your head. So what you do is you change it to base 10. That's what a common log is. And you put log 8 over log 5, and you punch in your calculator. You can also do natural log 8 over natural log 5, and you'll get the exact same answer. You can change it to any base you want to, but the reason we choose either common or natural log is that's what your calculator does. So I'm punching in it right now, log 8 over log 5, and I get 1.2920. You might have punched that in with me. The second one, I'm punching it in also, natural log 8. Make sure you close your parentheses over natural log 5. Got the exact same answer, because it doesn't matter what base you change it to as long as you change it to the same base. And again, these two bases are by far the most popular because your calculator does both of them. No need in changing a base 5 to a base 3 very often because your calculator doesn't do base 3. All right, log graphs. One last thing here, log graphs. The inverses of exponential graphs. Now, you may not remember this, but we talked about what makes inverses. They are reflections over this line, and exponential graphs did this. They kind of went like this. And so if you look at the red and the blue, they're reflected over that green line, which is what inverses do. Okay, let's look at the properties real quick. Oh, first of all, remember, logs are inverses of exponents. That graph right there just proves it. And what that means is everything that was, all your x's that were in your domain for exponential are now in your range, and your range becomes your domain. Everything just switched back and forth. When we did the exponential, the x-axis was the asymptote. Now the y-axis is the asymptote. All right, everything is completely switched. Okay, let's go through it real quick. It's continuous, which means there's no breaks, no holes in it. It's 1-to-1. It passes the horizontal line test. The domain just from 0 to infinity. So that's where it switched. The range is going up and down forever. We're talking about the red now. Up and down forever on your graph. So those are switched from the exponential. It's increasing, meaning the graph's going up from left to right. The y-axis is the asymptote. The x-intercept is 1, 0. When we used to do this on exponential, the y-intercept was 0, 1. And there is no y-intercept because the y-intercept is an asymptote. All right, this one says graph f of x equals log base 5 of x. Now, I'm going to freehand this because I forgot to take a picture of a coordinate plane. So here we go. No big deal. 1, 2, 3, 4, 5, 6. Remember the properties we just read. What I know is the x-intercept is 1, so I'm going to put a point at the 1. And that's true because if you put 1 in for x right there, 5 to what power is 1? Well, 5 to the 0 power is. That's why 1, 0 works. Now, the other point I'm going to plug in is I'm going to plug in whatever the base is. I'm going to plug in 5 for the x. And if I plug in 5 where the x is, it's basically asking me 5 to what power is 5. Well, 5 to the first power is. So what that means is 5, 1 is also a point. So 1, 2, 3, 4, 5, up 1. Now remember, the y-axis is an asymptote, so it's going to get closer and closer to the y. It's going to cross the x at 1 and come right through there. And that's what the graph's going to look like. And basically the 2 points I'm going to pick when I'm graphing by hand is I'm always going to pick the 1 because that's what it should be your x-intercept. And the other point I'm going to pick is whatever the base is. In this case it was 5. I'm going to put 5 in for x, and it's always going to be 1. If it was base 10, I'd pick 10. It'd be 10, 1. If it's base 3, I'd pick 3. It'd be 3, 1. So it's pretty easy to graph. All right, last thing here. Graph, I can't see it yet. Natural log x. Okay, so that's still a log. Only difference is base e. All right, so remember, e is really 2.71828, and it keeps on going. That's what e is. So Still, the properties of log graphs still work. The y-axis is still an asymptote. It's still going to cross the x-axis at 1. 1, 0 is the x-intercept, because if I put 1 right there, e to what power is 1? The 0 power. Okay, now the other point I'm going to pick is e, which means I'm going to go over to 2.71828. I'm going to estimate that, obviously, on my x-axis and go up 1. So if I go to almost to 3 and go up 1, there's my other point. So my other point is E1, because that was the base. Remember we talked about whatever the base is, that's what I'm putting in. The y-axis is an asymptote, so it gets closer and closer, then it pops up to the x-axis and goes just like that. That's your equation. That's your graph of natural log x. And you can punch it in your calculator and check it if you want to, but that's exactly what it looks like. All right, hope that wasn't too bad. We'll work on it tomorrow like we always do, and I will see you then.